Our last two examples are going to require more than just using either the reciprocal or quotient identities for some direct substitution, or even the Pythagorean identities to increase or decrease the number of terms in the expression. But on this first one, we're going to have to factor. So we can see on the left-hand side, we've got tangent squared times cosine, and we've got plus cosine. And so those two parts of the expression both have a cosine in them. If we think of this as maybe like a 5x squared plus 5. If we had a statement like that, we could all pretty easily identify that we could undistribute a 5 from both parts of the expression. And so then we'd have 5 times x squared plus 1. We have kind of a same situation happening here, except instead of with x's and numbers, we've got these trigonometric expressions. And so in both parts of this expression, I have a cosine. And so that's going to be what I'm going to factor out. Is I'm going to factor out a cosine and then see what's left behind. And so in the first part of the expression, if I undistribute that cosine, we'll be left with tangent squared plus, and then if I take out that cosine, I need something to hold the place, just like we did over here. When we factored out the 5, we needed a 1 to hold the place, so the same thing is true here with the cosine. So we've undistributed that cosine, and so now that's left us with tangent squared plus 1. Now one thing we might think of is to change that tangent into sine over cosine, but better for us in this circumstance is to recognize that tangent squared plus 1 is one of our Pythagorean identities. And this is also a place where we can look to see where are we headed. We're trying to end up with a secant eventually. So somehow I'm going to have to get, cosine is connected to secant because it's the reciprocal of secant. But that tangent squared plus 1 is somehow going to need to turn into cosine or secant. And indeed, tangent squared plus 1 is secant squared. So we can make that substitution. So I've got cosine times secant squared. So I at least now have my secant appearing in this left-hand side that I need to end up with. So now I need to end up with just secant instead of cosine times secant squared. So this time, instead of turning the secant squared into cosine, into 1 over cosine squared, I'm instead going to turn the cosine into 1 over secant. Because what that does for me now is sets up a little cross-canceling reducing that we can do. So the secant here takes out one of the two secants that I have in the numerator, and so we're indeed left with secant equals secant. Check. Boom. We'll go 2 exclamation points on that one. For our last example, we can see that we're adding together two fractions. And somehow those two fractions we have to add together to end up with that 2 cosecant squared that we have on the other side. Well, in order to add fractions, we have to have a common denominator. And as close as this 1 minus cosine and 1 plus cosine look, they have nothing in common with one another. They are as different as x plus 1 and x minus 1 from our previous study of adding and subtracting fractions with variables in them. And so I have no choice but to multiply the first fraction by 1 plus cosine on the top and bottom. And the second fraction has to get multiplied by 1 minus cosine on the top and bottom. So I still have the original fraction here times 1 minus cosine. So again, somehow, some way, this is eventually going to end up equaling 2 cosecant squared. So on the top, if we just focus on this fraction over here, I've got just 1 plus cosine over. Now on the bottom here, I have a little FOIL that I have to do. And so hopefully we can recognize this as being a difference of squares pattern, 1 plus cosine times 1 minus cosine. And so what we're going to end up with is 1 minus cosine squared. Because if I FOIL it, the 1 times 1 gives me 1. The positive cosine times the negative cosine gives me a negative cosine squared. But then those middle two terms, the cosine times 1 and the negative cosine times 1, are going to end up canceling out. And so then that means I'm going to end up with the same thing on the other part. So in the numerator, I just have 1 times 1 minus cosine, so I get 1 minus cosine. And in the bottom, I get that same denominator, 1 minus cosine squared. So now that we have a common denominator, we can combine these two into one fraction. So I've got 1 minus cosine squared on the bottom. And then up in the numerator, we can write everything all together. 1 plus cosine plus 1 minus cosine. And so hopefully we can see that in the top we can gather like terms. 1 plus 1 gives us 2. And then that positive cosine and that negative cosine cancel each other out. So that's all we're left with is the 2 up in the numerator. And then in the bottom, I still have this 1 minus cosine squared. So I can see the 2 has popped up. Again, we can always refer back to what is it that we're trying to turn our expression into. So we've got the 2, so somehow we need to end up with a cosecant squared. Well, how am I going to get a 1 minus cosine squared on the bottom to turn into a cosecant squared up in the top? Well, recall that cosecant squared is the reciprocal of sine squared. So I need to somehow turn that 1 minus cosine squared into a sine squared. Well, if we move over this way, 1 minus cosine squared is a variation of that original Pythagorean identity. If you go back and look, remember we can rearrange those identities, those Pythagorean identities into any variation where we move the pieces from one side to the other. So 1 minus cosine squared can be replaced with a sine squared. And so then finally, we've got sine squared in the bottom, which means I can replace that with a cosecant squared in the numerator. So I've got 2 times cosecant squared, and that's what we were aiming for. Check. Boom. We'll go with 3 that time, and we're done.